Hello, everybody. I think people are still busy on getting free T-shirts, but we have time limitations. I have 15 minutes, so I'll start over. Since July last year, that's the timing we finished all the validation tests on SynQuacer. Since that, we started distribution to potential customers and partners for the real machine evaluations. And we actually start having very good feedback from all those partners. And most of them are actually very unique, and they used something unexpected use cases. But I pick up some of the typical cases today. Okay. So first one is new DDT feature. This is for easy bare metal provisioning. DDT, we originally considered to use that function only for the internal networking. So to place the big data distributed inside the server and running all the CPU cores together. So that was the original use case. But because of that reason, we made the internal connection available, but all the other things like external connection, we expected people use the LAN cable for each connecting to each CPU card. But some of the potential customers, they really do not like many cables in front of the panel. So like picture on the left side. So only one server in the rack, probably it's still acceptable, but think about 20 of them all cabling. So it's not like no. Some of the partners said that's the cabling study. So we set up the driver for the network card. Now, only one connection using a SFP plus form factor, then the external connection can equally distribute to the internal CPU card. So it's up, and also because we did something in addition on that driver, we are now able to network booting. It says coming soon, but last Friday, we distributed the first draft version to the potential customers. I think they already started the evaluation. So this is the network card, how we connect. So before we design, while we were designing the motherboard, of course, we expected such a use case, so we intentionally placed the external accessory port for connecting to the Ethernet, not Ethernet, to Ethernet connecting to the PCI Express. And that PCI Express is the physical connection to the DDT. So this is how it connects. So one CPU card, we call that PEC, which stands for Processor Element Card. That PEC connect to the PCI Express to network card. That CPU work as a network card host and connecting to all other PECs internally. So the other connection, external Ethernet connection to that host PEC can distribute to the other PECs inside the server. So that means we have 32 CPU cards inside, so 31 for the real functions and one for dedicated for the network card. So in addition, we set up the network boot. So to deploy the bare metal provisioning, in our original DDT, we made a program on operation systems, OS. So that means when we turn on the server, until OS starts running, DDT will not work. So in that setting, bare metal provisioning will not work because all the end users, they need to choose the OS image from the list. And we need that OS image to distribute by DDT. So that means DDT must be on before OS start. So for that purpose, we implemented that DDT program into UEFI. So now DDT wakes up when UEFI, all the drivers starts running. Then network bootstrap program selects the OS image from the OS storage through the Pixie server. So that's how the network boot, Pixie boot, set it up. So it's almost ready, and not many players are doing bare metal service using ARM. So you can imagine who is doing this. So, but the good thing is having this, the existing bare metal service providers who has been a little bit hesitate to jumping into ARM, now they can start doing the test using our SynQuacer. So other use case, one example is the database system. So this is we got the access from Oracle Japan, MySQL team. And they said our ARM concept, little core, multi-core concept will be beneficial for their database system, especially on the MySQL cluster. So we consider the benefit doing this. MySQL cluster, they have management node and SQL node. SQL node is the database server. And that database server connects to the data node, which is the storage. And they connect, they're both scalable, SQL and the data nodes. But the problem is the connection between them. And most of the case, people are using RDMA, either Rocky or Infini band. But as you know, they are expensive. And then we consider putting everything inside our server system. We have 32 inside one unit. So we can connect, so we can scale both SQL and data node, which we can assign by ourselves. And inside the SQL node, once we assign the MySQL cluster, automatically distribute the task to the database node. And we can select the number of replication. If we pick 2, the data replication will be located automatically. And then we can also scale the data node. So having SynQuacer, we can achieve the high density, high availability, low latency, low cost solutions. So original idea of this MySQL cluster is for the high availability. They claims 99.999% availabilities. And we can also make a replication connecting through the optical cable on the back. So it will be even higher availability system. Okay, this is the benchmark result of the Sysbench OLTP result. So the two parameters we need to consider. One is the transaction per second on the left side, and right side is the response time for each transactions. So actually increasing the data node, increasing the number of threads, in either case, we never reach the bottleneck for anything. So CPU performance, networking, and IOs, we don't know how to reach the bottleneck yet. So what happens is, so we set up we started from the one SQL node, one data node. This is the original start point. And on the SQL node, we also installed the Sysbench. And because we have 24 cores in one CPU, so we set up the thread, number of Sysbench threads, 24. But having this and increasing the SQL node, then second and third SQL node are not functioning at higher usage. So they are like 10%, 15% CPU performance. So we thought probably increasing dispatcher will make that performance better. So we increased the Sysbench thread to 48, 72, and 96. Then SQL node starts working. But we have some disadvantage increasing number of Sysbench threads, because increasing threads that decrease the worse response time. So we need to balance the better response time and maximum Sysbench thread. So as you can see, the response time here, so it says 1 by 1, which means Sysbench 1 and data node 1. So we increased the Sysbench and the thread number of threads, 48, 1, 1, 2, 1, 2, 2. So that means we increase both SQL node and data node. And as you can see, increasing the number of nodes doesn't change. Actually, higher number of nodes decrease the response time. So that means we didn't reach the network bottleneck yet. In fact, when we measure the IPAF between the nodes, it's over 9 gig BPS because of DTT. But when we run the Sysbench, it's much lower because each packet not fully occupied. So only the 1,000 byte inside one packet. So it's not effectively loaded on the network side, but we can try to increase the nodes more. Then we'll see where will be the bottleneck of this entire system. Yes?
There is no numbers on the response time axis. Can you comment on that? How much the difference is?
Excuse me.
What are the numbers for the response time differences in that
number inside. One by one means.
No, I mean the axis. Like we have 0, 20, 40 on the number of threads, but there's no numbers on the vertical axis.
Vertical is response time. Real
Like what numbers? Like
real numbers, it's still unofficial. Okay, same on the TPS. Okay, so the other thing is the real application running on SynQuacer. So this is somehow VMS, video management system. 3 vendors already converted their application to SynQuacer. And actually, Eli by Zorachka, that was the first trial. And we have found that the balance of the CPU performance, CPU core, and the memory bandwidth is very good fit on such applications. And we got approach from Network Optics and Axon Soft, and they are all running okay. And they all have different expertise on their software side. For example, Network Optics, their software is very flexible, and there are so many add-on capabilities. So we can put AI functions onto their VMS software. So Eli software on Zorachka, it's designed for very low latency, and the image on that screen is actually iPhone's shot, image shot. So it's the server is located in Hokkaido island in Japan, North area, and using one developer kit and connecting multi-camera, and then we can see by the iPhone. So that's at very low latency. And the third one is the Axon Soft. They connect 300 cameras into one developer kit, and it's running. So they are all unique. Okay, so for Friday, demo Friday, we will present network optics. So we have AI plugin, and we'll demonstrate using developer kit with AI module, which we use the chip from Jill Falcon. He is a representative from Jill Falcon. He will have another session afternoon, so I hope you will join that as well. So please come to our booth on Friday. Thank you very much.